Hello everyone, welcome to MRU E-Learning powered by Malla Reddy University. Myself, Dr. G. Anand Kumar, the head of the Department for Electronics and Communication Engineering, School of Engineering at Malla Reddy University. Today, we are going to explore how explainable AI in IoT-enabled healthcare devices is transforming the future of medicine from an electronics and communication engineering perspective. So, here is the agenda for today's presentation. So, we'll start with the introduction to the explainable AI, and then we'll move into the role of electronics and communication engineering in IoT healthcare. From there, we'll see how AI is being used in the IoT healthcare and what exactly the challenges that traditional AI will faces. Next, I'll give you an overview of XAI and then how it applies to the healthcare devices and system architecture. We'll also explore some XAI methods and the frameworks also. We all know that trust and security are very vital nowadays, so we'll look forward at Federated XAI for the privacy, security, as well as the blockchain with XAI for trustworthy IoT systems. We'll then move into the exciting applications like the digital twins, AR, VR, and XAI in the healthcare. And also, we'll see how 6G and RIS technologies can enhance IoT with XAI. Finally, we'll talk about XAI in the cybersecurity, green and sustainable IoT with XAI, and then we'll wrap up with the research and the career opportunities in electronics and communication engineering. So, the overall flow is designed to take you from the basics of XAI into the technical application aspects and finally into the futuristic trends and opportunities. So, you all might have noticed how common these IoT devices have become nowadays. The smartwatches that check our heartbeat, glucose monitors for the diabetic patients, or even the tiny devices that is being implanted in the body. The challenge is, when these devices use AI for the diagnosis, they often behave like a black box. That means they give us the results, but they don't explain how they got them. So let me ask you this. Would you trust a device that says you might have a heart attack but doesn't tell you the reason why? Most of us would say no. Because in healthcare, we always want to know the reason behind the decision. That's where the explainable AI, XAI, comes into existence. XAI does not only give us the results, it just gives us the explanations too. Let me make you all very clear with a simple example of a smartwatch that is being used with an artificial intelligence versus the XAI. If you're considering the AI in healthcare, a smartwatch monitors your ECG signals and it shows you a notification, abnormal heartbeat detected. Just a simple abnormal heartbeat detected. Yes, that information is definitely useful, but it is not clear. Why? In that case, doctors and patients may hesitate to trust it. Whereas, if you're considering the XAI, the explainable AI, instead of just giving you the result, it also explains the reason too. That is, the abnormal heartbeat detected. The P wave is missing, which is nothing but the arrhythmia. What exactly is the P wave? Let me show you on this slide. The P wave is just the first small bump in an electrocardiogram reading. You can see here, you can observe here in this. So it shows the arterial contractions, the upper chambers of the heart that is being pumping that particular blood. So if that particular P wave is missing, it usually means the arteria are not contracting properly. Whereas that arrhythmia is a condition where that heart detects an irregular rhythm, either too fast or too slow or in an erratic fashion. So, when your smartwatch or a kind of AI system says that particular P wave is missing, which indicates that arrhythmia, is basically telling you your heart's normal rhythm signal. That means the P wave is not showing up. It's a sign your heartbeat is abnormal, yes, a possible arrhythmia. So doctors immediately understand the cause of the medical reason. Whereas patients also gain that particular confidence because they see how this artificial intelligence has been reached to that particular decision. That's the kind of clarity the doctors and the patients will need. If we are considering a Philips ICU monitoring system also, the traditional system only shows the vague alerts like the patient unstable with XAI. It explained that particular oxygen level, dropping levels also, which is being due to the lung failure. That helps the doctors to take quicker decisions or to the better decisions. Yes, obviously explanation saves the lives. So before we go deeper into this, let us quickly understand what exactly is the difference between AI, generative AI, and then the explainable AI. So AI, the most important technology which we all have been using nowadays, artificial intelligence, which is a broad field that machines learn from the data and makes the predictions or the decisions. For example, AI model can analyze that particular ECG signal and say it looks like an arrhythmia. Whereas, if you're considering the case of a generative AI, this is also a type of AI that can create a new content like the kind of text, images, or even the synthetic medical data. So a generative AI system can generate a realistic chest X-ray for training that particular doctors. Whereas if you're considering this XAI, the XAI is not only makes the prediction, but also explains you the reason behind it. So XAI system doesn't chase that particular arrhythmia is being detected. It acts because the P wave is missing in your ECG. So in simple words, I can say that AI is for the decision making, Gen AI is for the content creation, and explainable AI is for the transparent explanation of that particular decisions. So my presentation totally focuses mainly on XAI in IoT healthcare, because in medicine, trust and explanation are as important as accuracy, because healthcare decisions are always the life and the death. Doctors and patients need to know why an AI gives a certain result before trusting it. For example, if an AI predicts a 70% chance of a stroke, doctors want to know, is it due to the blood pressure or to the cholesterol or due to the ECG signals? That's the reason why XAI plays a very vital role in the healthcare. Let's move on to the next slide. Now, the important concept, the role of electronics and communication engineer in an IoT healthcare. ECE, the backbone of IoT healthcare system. Now that we have set the stage with the first slide, the introduction of XAI, let's talk about the role of electronics and communication engineering in an IoT healthcare perspective. So whenever we think of IoT healthcare, we usually focus on the software side aspect itself, where AI, apps, or cloud platforms. But the truth is, without electronics and communication engineering technologies, none of these systems could even exist. So friends, I can say you that this electronics and communication engineering provides the hardware, sensors, communication channels, and signal processing techniques that makes all these IoT healthcare devices possible. You can see here in this particular diagram. This diagram shows you how the electronics and communication engineering supports that particular IoT healthcare. So first, this ECE provides the hardware, the sensors, circuits, and all the processes. So all these enables the IoT devices like the smartwatches and the medical monitors to collect that particular patient's data. Then through the communication technologies like Wi-Fi, Bluetooth, and 5G. So the data is securely transmitted then to the AI and then the explainable AI, which analyzes the data and provides the basic insights for the doctor. So the final result is a strong healthcare impact with better monitoring, early diagnosis, and improved patient care. That is what we require in a healthcare right now. So in short, I can tell you all is, ECE drives the entire process from devices to the healthcare opportunities. Let me explain you all this in details. Firstly, the sensors and the biomedical devices. So at the very foundation level are the sensors which are being developed by an electronics and communication engineers itself. So these sensors captures the vital signals from the human body, the ECG electrodes for the heart signals, SpO2 sensors for the oxygen saturation, pressure sensors for the blood pressure, and glucose sensors for the diabetic monitoring. So without accurate sensors, there is no input data for AI to analyze. So in simple terms, there is no input data for AI to analyze at all, or sensors are the eyes and the ears of any kind of IoT healthcare systems. Then comes the signal processing, where the entire processing is done by this particular system. So once the data is being captured, it is not immediately usable. So the real-world biomedical signals are usually noisy and distorted. For example, if you're considering the same ECG data itself, it can be disturbed by the muscle activity or even the movement of that particular patient's hand also. So electronics and communication engineering contributes the advanced signal processing techniques like filtering, amplification, feature extraction. So these methods clean the signal and highlight some sort of important features like the P wave in the ECG, which is very crucial for determining the arrhythmia. So here, electronics and communication engineering ensures that AI doesn't receive any kind of garbage data, but instead it provides the precise, high-quality input. Then the communication role comes into existence, the wireless communication nowadays. How does this clean data move from the patient to the doctor? This is where the communication engineering role comes in. IoT devices use all these technologies like Bluetooth, Wi-Fi, Bluetooth for the short-range wearables, Wi-Fi for hospital monitoring systems, and 5G or NB IoT for remote rural healthcare applications. So these protocols ensures the low-power, reliable, and real-time transmission of that particular health data. So if a smartwatch detects an abnormal heartbeat, the electronics and communication engineering system makes sure that this data reaches to the cloud or to the doctor instantly so that he can take the decisions immediately. Then comes the role of the embedded systems and the hardware design. So inside every wearables or any kind of implanted devices we consider nowadays is obviously a miniature computer, where everyone will be having their smartwatches in their hands also, where microcontrollers, processors, and even the low-power chips. So the electronics and communication engineers design these embedded systems to be very compact, power-efficient, and reliable. For example, an implantable pacemaker also. It needs to work continuously on a very small battery. That is possible because of electronics and communication engineering's focus on low-power circuit design. Very log integrated circuits, VLSI. So this electronics and communication engineering ensures the brains of IoT devices work efficiently without draining that particular power. So once everything is being done, then it has to be transmitted and the proper security has to be provided. That's where the role of data transmission and the security comes in. So whenever we are transmitting any kind of medical data, security and accuracy are as important as crucial. So the electronics and communication engineer, they enables encryption, error correction, and secure communication protocols so that the patient's data is being not intercepted or it is being tampered with any kind of things. So this is essential because healthcare data is extremely sensitive and protected by the regulations. So here, ECE ensures both trust and the reliability. Then an integration finally with the AI. Finally, the bridge between hardware and the AI is also provided by an electronics and communication engineer. So devices capture the signals, it processes them, transmit them, and then feed into the AI models either on the device, that means XAI, or on the cloud. So without this electronics and communication engineering driven pipeline, artificial intelligence would have nothing to analyze at all. So in summary from this slide, I can say that electronics and communication engineering forms the backbone of IoT healthcare because the sensors collect the data, signal processing cleans it, embedded systems handles it, communication networks transmits it, security protocols protects it, and finally the AI interprets it. So when AI often gets that particular spotlight, it is the role of an electronics and communication engineer that quietly makes all of this possible. Let me give you a simple example, like the Apple Watch, where ECG feature is a great example of ECE plus IoT. It can detect any kind of arterial fibrillation. Now imagine if it is being used with XAI too. So instead of just saying arrhythmia is detected, it could also say that arrhythmia detected because of so-and-so reason, like P-wave is missing, which builds more trust. How many of you are using that particular smartwatch having the health feature before? Most of us have at least seen once, whether it is an Apple Watch or a Fitbit or a noise. So they all tell us the heart rate, sleep cycles, and sometimes even the oxygen levels too. That's IoT plus ECE in action. Sensors, circuits, wireless communications, all working together with AI. Or similar to this, have you ever seen a smartwatch or a phone telling you something like time to stand up or your heart rate is high? If yes, that's IoT plus AI in action. If no, well, imagine your phone is not warning you, but it's also explaining why it thinks your heart rate is high. That's where this explainable AI. Let's move on to the next slide. AI in IoT healthcare systems. Now, we understand the basics of AI and XAI. Let's look at how artificial intelligence is currently used in IoT-based healthcare systems. So this diagram highlights the role of artificial intelligence in IoT-based healthcare systems. So at the center, you can observe AI, which acts as a brain. So it analyzes, interprets, and making sense of large volumes of health data that is being collected from the different IoT sources. Then the wearables. So these wearables like the smartwatches always track our health. The connected devices send medical data to that particular doctors. AI acts like the brain. So the cloud stores all that particular data safely. So AI takes all this information, understands it, and helps the doctors to make the faster and the smarter decisions. That's why the patients get better care and even the remote monitoring becomes possible. So AI with IoT in the healthcare. Firstly, continuous monitoring of that particular visual signals. IoT devices like the smartwatches, the fitness trackers, or the glucose monitors, and implantable sensors, all these things collects the data continuously, like the data like the heart rate, blood pressure, oxygen saturation, and even the glucose levels. So AI comes into play by analyzing this constant stream of data in the real time. Unlike a doctor who sees you maybe once in a month, AI-enabled IoT devices can keep track of your health 24/7. Predictive diagnosis and early alerts. So one of the biggest advantage of AI is the predictive capability. For example, AI can detect the unusual heartbeat rhythms that may signal an upcoming arrhythmia, or it can identify the sudden spikes in the blood sugar. So that warns a diabetic emergency. That means doctors and patients can take action before major medical event occurs, like a stroke or heart attack or any kind of hypoglycemic shocks like that. Then the another feature is personalized treatment suggestions. So AI doesn't treat all the patients the same. So it adapts based on your personal medical history, the lifestyle, and even the genetic factors. For example, two patients with the same heart conditions may get the different treatment recommendations depending on their age, diet, or whatever the activity levels they are doing. So AI helps the doctors design the personalized treatment plans instead of one size fit for all the solutions. Then comes the remote patient monitoring. So remote patient monitoring is a game changer, especially for any kind of elderly patients or those living in rural areas like who are having the limited access to the hospitals. So IoT devices send health data to that particular cloud where AI analyzes it. Doctors can log in and review the reports without the patient visiting that particular hospital. How beauty it is. So that reduces hospital crowding and lowers the healthcare costs and even ensures the continuous care from the home. Then the AI-driven the medical image analysis. Beyond the wearables, AI is heavily used in analyzing that any kind of medical image like X-rays, CT scans, MRIs, or any kind of ECG patterns. So AI can highlight any kind of suspicious line spot on an X-ray that a human doctor might be missed in that particular busy schedule. So that increases the diagnostic speed and accuracy, supporting doctors rather than replacing them. Further example to simplify, let's say You're wearing a smartwatch. It records your ECG signals. The AI in watch analyzes that particular pattern, which gives us the alert like arrhythmia risk detected, which is the irregular heartbeat observed. So this is extremely useful because it provides the early warning. The patient can consult a particular doctor right away immediately. But here's the challenge. Traditional AI stops you there. It shares that the arrhythmia risk, but doesn't explain you the reasoning. Was that particular PVS missing or not? Or was the heartbeat is too fast? So this lack of explanation is why the doctors sometimes hesitate to fully trust that particular artificial intelligence. And that brings us the importance of explainable AI, XAI, which closes the gap that providing some kind of transparency. XAI doesn't say the arrhythmia risk. It's tell you the reason why. So that's the critical next step we will be going to explore. For example, let's consider the case study of a Google. So Google also built an AI system for detecting the diabetic retinopathy, which is for the eye disease. So at first, doctors didn't trust it at all. It was just a black box. But after adding this XAI feature, highlighting which part of the retina was damaged, doctors in Indian hospitals also started using it widely. So now my question to you is, if you were a doctor, would you trust a black box AI or the one that explains itself? Obviously the explainable one. Because no doctor will take a risk without understanding the reasoning. That's the importance of AI in IoT healthcare. Now, let us see what exactly are the challenges that traditional AI faces. As you can see here in this particular diagram, this diagram in this slide highlights the key challenges we face in the traditional AI models. Although AI is being powerful, it often comes with some sort of limitations that affects its trustworthiness and usability, especially in the sensitive areas like healthcare, finance, and law. The first one is the black box nature. That means the lack of transparency problem. So most of the AI models, especially the deep learning, the convolution neural networks, or RNNs, or transformers, all these things operate as the black boxes. So they generate the outputs, so without telling us how they reach to that particular decision. So in healthcare, where human life is at stake, this lack of interpretability is a major barrier. So doctors cannot prescribe the treatment based on that particular AI's decision unless they understand the reasoning behind it. Let us consider a simple case of a healthcare. We all have been working in the research with a deep learning model. So whatever the deep learning model, we have been trained on that particular chest race, reported that kind of tumor is being detected. However, it doesn't explain any kind of pixel regions or image features that is lead to the conclusion. So when doctors investigated, they found the model sometimes rely on that irrelevant pattern, like markings on that X-ray image or rather than any kind of medical features. So this reduces the doctor's trust, proving the need that AI explains its reasoning also. Then bias in that particular data, which is an unfair predictions. AI learns from the historical data because we have been training that particular system. So if that data is being biased, the AI will carry forward those same prejudices. In healthcare, data imbalance, like more male patients than the female, or more data than one authenticity than another, all these leads to the unfair predictions. It happens some sort of, if you're considering the case study in the recruitment bias of the Amazon AI recruitment system is totally scrapped after it because the system downgraded the female applicants. The system learned from the past resumes, which were mostly the male, and concluded men were more suitable, reinforcing the gender bias. Even in the case of the healthcare also, a heart disease prediction model trained on predominantly male datasets underestimated the risks in women. As a result, women received less accurate diagnosis when compared to the men. This is extremely dangerous in medicine, as biased predictions can mean life or death. The other important challenge here of XAI is the data privacy and the security concerns. So AI requires a massive data, as we already discussed. So in healthcare, these data sets include the private information, the medical histories, scans, genetic data, and even the behavioral patterns also. So if that data sharing is not transparent or if it is not secured, patients will definitely lose the trust in both the hospitals as well as artificial intelligence. The same thing happened in the study of Google's Project Nightingale. In 2020, Google partners with Ascension, a large US hospital chain, to develop the AI tools for the patient care. However, millions of patient records were shared without clear communication to the patients or to the doctors. Then there is a strong negative reaction by the large number of people. The public highlighted the lack of transparency in the data handling, and many questioned whether Google was using sensitive data ethically or not. This shows how privacy concerns can overshadow the potential benefits of the artificial intelligence. And the challenge is the high computational cost and the energy use. Training the modern AI systems like the GPTs, which is a generative pre-trained transformer, or the convolutional neural networks, the deep convolutional neural networks, which we are using for the research for imaging, or LLMs for the diagnosis, all these things require enormous computing powers itself. Advanced GPUs, TPUs, or any high electricity consumption, even for the smaller hospitals and startups also, these costs are prohibitive. With XAI, it's just a big challenge. Then, the limited trust in the critical fields like the healthcare. Yes, trust is a foundation of critical decision-making fields because patients trust the doctors because they explain that particular treatment. Clients trust the financial advisors because they justify the investment advice. AI, however, often delivers a decision without any kind of reason. How beautiful it is. If you're considering the case of a finance, if a bank's AI model denies a loan application, customers will naturally ask, why was I rejected? So if the AI cannot explain whether it was due to the credit history, income, or risk category, that decision definitely feels unfair. Even in the case of the healthcare. An AI tool may flag a patient as a high risk of heart attack, but unless it explains which biomarkers like cholesterol or ECG or family history, etc. like that, that leads to the conclusion doctors cannot justify the medication or the surgery. So in life critical domains, a decision without an explanation is equal to no trust. Finally, what I want to conclude from this slide is these challenges like the black box nature, bias, privacy risk, high computational costs, limited trust, that means the lack of trust of these technologies, all these things clearly shows why traditional AI cannot be blindly deployed in healthcare or any other critical fields. That's where this XAI comes in. It doesn't just give you the answer, it provides you the reasoning. It highlights its contributing factors and allows humans to understand the trust and verify that particular decisions. So these challenges highlight the need for explainable AI to make AI more transparent, fair, and trustworthy. Let's move on to the next slide. The overview of explainable AI. So we have seen the basic introduction of an explainable AI, the difference between AI and XAI. Traditional AI is often called as a black box, where users doesn't know how it works. So this explainable AI solves that particular problem by making decisions more transparent and interpretable. In short, I can tell you that it's not just about what AI predicts, but why it predicts. So what is XAI? XAI provides you the human understandable explanations of any kind of AI decisions. Example, instead of just saying the loan is denied, it also explains the reason why the loan is being denied. Either it might be the income that is being less than 3 lakhs or the credit score that is being less than 650 or whatever it may be. That's the beauty of this XAI. Then the key goals. Let's take a moment to explore all these things, the goals of this XAI. At the center, you can see here the explainable AI. So a concept that emphasizes the need for AI systems to provide understandable and interpretable outcomes to that particular humans. That's XAI. So surrounding this core idea of there are 4 key pillars if you can observe in this particular diagram. So it supports the transparency, fairness, trust, and accountability. All the transparency that is being represented by the eye icon. Transparency ensures that we see how and why an AI system reaches its conclusion. This is essential for users, developers, and regulators to understand the inner working of any kind of complex model. Then obviously the trust, which is being illustrated by the handshake. Trust is built when users feel confident that the AI system behaves reliably and predictably. So when decisions are explainable, trust naturally increases because users can validate that particular outcomes. Then the accountability, which is being projected here with a shield icon. Accountability means that when AI makes a mistake or causes a human harm, someone can be held responsible. So explainability helps you to trace the decisions, making paths, and assign responsibility appropriately. Then the fairness that is being depicted by the balanced scale. Fairness ensures that AI does not discriminate or cause unjust outcomes. So when we can explain that particular decisions, we can also able to identify the correct biases that is being promoting equitable treatment for all the users. So together, all these four elements makes the AI more human-centric, ethical, and aligned with the societal values. So explainability is not just a technical feature, it is a bridge to responsible AI adoption. Then comes to the techniques of XAI. All these are the challenges. So this first technique is LIME, which is Local Interpretable Model Agnostic Explanation. So the main strength in this model is it's agnostic, intuitive, it is good for clinical patient conversations. So for this patient, these three features drove that particular alert, but the only limitation here is it is computationally heavy at interference explanations and can carry with the sampling. Then comes the SHAP, which is Shapley Adaptive Explanations. So this is based on the game theory. It shows some sort of feature contributions. The main strengths here are it is theoretically grounded, it is consistent for both local as well as global. But the limitation here in this SHAP is it is expensive. Approximations needed for the deep neural networks must be careful with the corrected features, correlated features. Then the decision trees, which we are all aware of this, decision trees and rule-based methods. All these things are easy to interpret directly. All these models whose structure is explanations, human can read the splits or the rules directly. Why they are great in healthcare? So transparent by the design, easy to audit, trivial to justify to the clinicians. So perfect for any kind of edge devices with a limited power. The only limitations in this is it may underperform also. So the deepness on complex signals or images, unless engineered features are strong, large trees can become bushy or even pruning or the shallow ensembles with surrogate rules also. The other technique is the attention maps in the deep learning. This highlights which part of an image or text that is being influenced by that particular decision. Like in the case of a medical imaging, XAI model also highlights the tumor region that lead to the cancer prediction. Putting it together, all these techniques, LIME will explain you the prediction locally, whereas the SHAP gives you the fair attributions locally and globally. Tree rules are explanations by the design. Attention or GradCM shows where the network is being looked. So in IoT healthcare, we mix these based on the audience, that means the patients or the clinicians, and compute the budget to deliver the trustworthy, actionable, and resource-aware explanations. Coming to the applications of XAI, yes, we have been discussing that it is used in healthcare, where doctors not only get the diagnosis, but also get the reasoning. Then in the finance, where the loan approvals or the rejections with the clear reasons to avoid the lawsuits by any kind of biased lawsuits. Then the law governance, judicial AI tools with transparent reasoning, all these things will prevent unfair outcomes. Then even in an autonomous systems also, or autonomous vehicles, all these things, decisions like why a car braked suddenly, so So that increases safety and the user's confidence. Finally, what I want to conclude you all from this slide is XAI bridges the gap between AI accuracy and the human trust. It's not enough for AI to be smart. It must also be understandable and fair. That's what exactly the biggest challenge of XAI or the explainable AI. Now let us see the system architecture of explainable AI. As you can see here in this diagram shows how explainable AI is being integrated into an IoT-based healthcare system to make the medical insights more trustworthy, more transparent, and usable by the doctors and the patients. At the bottom, you can see here, we have the sensors layer. So these are the biomedical sensors like ECG or EEG or glucose and SpO2 sensors. So which continuously collect the real-time patient data. Then comes the edge layer. So this data that is being collected from the sensors first goes to that particular edge layer, where embedded system processes and filters that particular data, so it reduces the noise and improves accuracy and avoids any kind of overloading that is being done by the system by sending only meaningful information forwarded. Then the data has been transmitted to the communication layer, which comes into the play, where technologies like the Bluetooth, LoRa, for long-range communications, Wi-Fi, and the 5G, all this for the user for the data transfer, the patient's data securely and reliably to the higher layers. Then comes the XAI. So this is the explainable AI layer, which is the key part of this particular architecture. So instead of just giving the raw predictions, XAI generates the explanations. For example, it can tell you, a doctor, not only that a patient may be the risk of arrhythmia, but also which sensor readings and patterns lead to that particular conclusion. And then finally to the user interface. So finally, the results and explanations are delivered through the user interface, which could be a mobile apps or a dashboards or a smartwatches. So doctors and patients can easily understand the health status and AI insights in the transparent manner, which builds trust and helps in timely decisions. So in short, this entire architecture shows how IoT sensors, edge computing, communication technologies, and XAI comes together to form a complete healthcare ecosystem that is intelligent, transparent, and user-friendly. Now, let us move on to the XAI methods and their frameworks. To start with, why these methods matter. Now that we know XAI is essential for the IoT healthcare systems, my question is, how do we actually make AI explainable? So that's where these methods comes in. AI in healthcare can sometimes feel like a black box. It gives you a result, but you don't know why. So post hoc methods are like the flashlights itself that shine inside that black box and shows us what the AI was actually or the really thinking for. As we have seen, there are some post hoc methods like LIME, which have been discussed in the previous slide. So LIME is like an AI saying, this particular bump in ECG line is the reason I suspected an irregular heartbeat. So it tells us which part of the signal mattered the most. Whereas SHAP, this SHAP is like a team sport. So your heart rate, blood sugar, oxygen levels are like the players in a cricket match. So SHAP tells us how many runs each player contributed to that particular final score, or in this case, how much each health factor influenced the AI's decision. Then comes the saliency maps. So these are like the highlighters for the medical images. So if a doctor looks at the X-ray, the AI highlights the exact spot it focused on. For example, a cloudy area in the lung. So that helps the doctors check whether the AI is paying attention to the right place or not. Then counterfactual explanations. So this is what if that particular tool. So it answers the questions like, what if the glucose level was 10 units lower? So AI might say, then the diagnosis would be normal. So this helps the patients understand with small changes in the lifestyle or health could really make a difference. So overall, these methods don't just give you the answers, they give you the reasons also, which makes AI more trustworthy for doctors and the patients. Then comes the intrinsic explainability models. So intrinsic explainability refers to the AI models that are being interpretable by that particular design, meaning we can directly understand how they make the decisions without needing any kind of extra explanation tools like the decision trees. So in this decision trees, each branch represents a decision rule. So we can trace exactly how the model arrives at an outcome step by step, even if you're considering the rule-based methods. So these models use if-then rules, making their logic more transparent and easy for humans to follow that particular rule. Then the GLMs, which is the generalized linear models, like logistic regression. This provides coefficients that clearly shows the influence of each feature on the prediction, making them naturally interpretable. Finally, I want to wrap up for this slide. Together, all these frameworks or all these methods forms a backbone of explainability. Whatever we study, LMME, SHAP or salient maps or whatever it may be. So in IoT healthcare, combining the post hoc and intrinsic methods ensures patients and doctors can trust what the AI is doing. Coming to the next slide, the Federated XAI for privacy preserving IoT. So in IoT healthcare, privacy is a huge concern. We cannot risk sending all patients' ECG glucose levels or the brain signals to the central cloud. Federated learning solves that particular problem by training AI models locally on each device. And only the sharing the learned knowledge, not the sensitive data. So how it is being linked to that particular XAI? Now imagine combining this with an XAI, each device can also generate the local explanations. For example, a glucose monitor might explain glucose predicted high because 3 consecutive readings are more than 200 mg or something like that. So this explanation is shared safely without exposing the private records. For example, if you're considering the case of Google's Gboard, so Google's Gboard keyboard uses that particular FL, that means without XAI. So in healthcare, Federated XAI could allow the multiple hospitals to collaborate on a cancer detection model without ever sharing the parent scans directly. As you can see here in this particular diagram of Federated XAI, so Federated XAI enables a privacy-preserving healthcare IoT. Patients' data from that particular wearables and sensors is being processed locally. So with explainable AI. So no raw data leaves that particular device. Instead, only the model updates are shared with this federated server, which builds a totally global model. So this global model provides accurate predictions and transparent explanations for the doctors and patients, ensuring the privacy, explainability, and accuracy all at once. Finally, I want to wrap up for this particular slide. This is the future, secure, private, and explainable AI, making IoT in healthcare both effective and trustworthy. Then comes the blockchain with XAI, which is the trustworthy IoT ecosystems. So, in IoT healthcare, it's not enough to just predict. We must also guarantee that the data and AI decision-making process are trustworthy. So data can be tampered with cyber attacks. AI can give an opaque black box results. So blockchain ensures the data integrity and traceability. This XAI for the blockchain, it ensures a transparent decision making. So together, a trustworthy healthcare ecosystem is being developed with blockchain and the XAI rule. If you consider the role of a blockchain, every data transaction, either the heart rate, glucose, or ECG signal from IoT devices is being recorded on a blockchain ledger. So this makes it impossible for hackers or insiders to secretly alter the health data. Even the patients and doctors can audit the history of all the records. So what exactly is the role of XAI in the blockchain? So blockchain generates the data trust, but AI predictions still need interpretability. So XAI explains, for example, insulin dose recommended because glucose trend rising post-lunch by 30%. That is how this XAI explains for this blockchain. So the combined benefit here is blockchain ensures the prediction is based on the authentic data. XAI ensures the prediction is explainable and trustworthy. So together they build end-to-end trust in IoT healthcare. So if you're considering a simple case study, a hospital IoT system monitors the patients remotely. Blockchain prevents the tampering of ECG or glucose readings. XAI explains the AI decisions like arrhythmia risk flagged due to that particular missing P wave. The result is both data integrity plus decision transparency. That's where the blockchain plays a vital role in XAI. Coming to the digital twin plus AR VR with XAI in IoT healthcare. So here, this slide shows how the digital twins, AR, VR and explainable AI come together in IoT-based healthcare systems. So as you can see here in this diagram, at the bottom, we start with the IoT sensors. So these are the devices like the heart monitors or the glucose sensors and wearables that continuously collect the patient's health data. So that data is used to build a digital twin, a virtual replica of the patient's heart or body. So doctors can use this particular digital twin to run the simulations and see what's happening inside the patient without invasive procedures. On the top of this sensors, we have the digital twin or that particular AR-VR interfaces. If you're considering AR-VR interfaces, for example, a surgeon wearing an AR glasses can literally see the patient's digital twin in a 3D model with problem areas that is being highlighted. So here where XAI adds a value to this particular system. The system doesn't just show you a 3D heart, it also explains why there is a concern. So instead of just saying a surgery needed, the system says surgery needed because this artery doctors to interact with these twins in the real time. And XAI explains you the reasoning behind all these kind of predictions. For example, instead of just saying surgery needed, it shows the artery is 80% blocked due to the plaque buildup. So together, these technologies makes IoT healthcare more precise, immersive and trustworthy. That's the beauty of digital twins or AR, VR in XAI systems. Then comes the another important concept of 6G and RIS-enabled IoT with XAI. So let me explain this in a simple way. 6G is the next generation after the 5G. So while 5G supports things like video consultation, 6G will allow you the real-time remote surgery. Let's imagine a doctor in New York operating on a patient in Hyderabad with robotic arms. So 6G makes that safe by giving almost zero delay. But hospitals have lots of walls and machines and signals often even gets break. That's where this RIS panels comes in. So think of them as a smart mirrors for wireless signals. So they bend and guide the signal so that devices like ICU monitors or AR/VR glasses always stay connected without any kind of interruption. Now, all these networks are run by the AI. So which device decides which device or the patient gets priority? So without explanations, it feels like a black box. That's why the XAI, explainable AI, is so important. For example, it can say, this ICU monitor got more bandwidth because the patient's oxygen was dropping. So in short, I can tell you all is, 6G gives us the speed. RIS makes signals reliable. XAI explains the AI decisions, which is critical in the healthcare where lives are on that particular line. Let me explain you with a simple diagram of this. So imagine a patient in a rural area who suddenly develops a serious health problem. So this smartwatch instantly detects the abnormal ECG and oxygen levels and sends the data to the nearby edge AI systems. So this edge AI system analyzes it in the real time. So within milliseconds, the AI identifies a critical issue and triggers an alert. Then the information is being transmitted to the 6G network. That's thanks to the ultra low latency and the terahertz capacity. The data reaches specialists in a city hospital almost instantly without any lag or the data loss. Now, the medical robot in the local clinic can be guided remotely by an expert surgeon using either whatever we studied in the previous slide, AR/VR assisted visualization. So, the surgeon sees the real-time imaging from a 3D scanner and performs a precise procedure as if they're standing right next to that particular patient and perform the operation of that particular patient. So in the ICU, doctors monitor the patients remotely with continuous real-time updates supported by the network optimizations that ensures unpredicted care. This is the promise of 6G-enabled healthcare. Distance no longer limits access to the expert treatments. Emergencies get immediate response and patients receive world-class care anytime, anywhere. Another important aspect is the cybersecurity. How this XAI, the explainable AI, plays a vital role in the case of cybersecurity. Think about how fast the cyber attacks that is being happening nowadays in the society are everywhere. Within the seconds, a threat can spread across the networks. That's where this automation comes in. So instead of waiting for a human to respond, AI can detect and react in a real time. But automation alone is not enough. Because attackers are constantly changing their tactics all the time. That's why we need the kind of intelligence. So AI that can adapt and learn from the new attack patterns. So instead of only relying on the old signatures or the fixed rule, now the challenge with AI in cybersecurity has always been the trust. So analysts often see an alert but don't know why the system is being flagged it. That's the black box problem. So with XAI, every action is justified and trustworthy. Let me explain you with an example. The automation, which is the real-time defense. So traditionally, a security team even takes hours or even days to respond to any kind of phishing attack or a malware outbreak. So with XAI-powered automation, the system doesn't just flag a threat. It acts immediately by isolating the infected device, blocking malicious IPs, or quarantining any kind of suspicious files. Importantly, it explains you why it did that. Then comes the role of intelligence in cybersecurity, where adaptive learning from the attacks will be taking place. Hackers keep changing their tactics. XAI learns and adapts quickly to that particular changes. For example, it can spot any kind of unusual activity, like an employee opening a patient files at the midnight and explain why that's suspicious, how beauty it is. Then the trustworthiness, human plus an AI collaboration. So people often don't trust AI because it feels like a black box. XAI solves by giving that particular reasons. Instead of just saying the login is risky, it explains it came from a strange location and bypassed security before. So this builds you the trust, especially for any kind of compliance heavy industries like finance or healthcare or even in the kinds of defense systems. Coming to the applications, intrusion detection and anomaly detection. Intrusion detection and anomaly detection is a spot unusual behavior inside any kind of particular network. Malware analysis and prevention. So it quickly identifies which malicious files or code that are being present in that. Phishing and fraud detection. So XAI catches the suspicious emails or any kind of financial activities Then the identity and access management, where secure login, authentication, and authorization is being required, which plays the vital role for this XAI in cybersecurity. So what exactly are the benefits of XAI? It doesn't just raise an alert. It explains why the alert was triggered. Example, any kind of suspicious login because of TOR use and any kind of unusual location. So that increases the trust for any kind of SOC teams. They understand systems reasoning instead of blindly following that particular alerts. So it supports the compliance and the audits by providing the clear explanations, which is crucial for any kind of regulations like GDPR, HIPAA, etc., something like that. HIPAA, which is the health insurance portability, and GDPR for the general data protection regulation authorities that are there. Let us explain the role of cybersecurity in XAI in this particular diagram. So, this diagram compares the traditional black box AI models with explainable AI models in the cybersecurity. So, let's break down from one after the other. So, on the left, you can see here, we start with detailed data systems. The raw input that is being processed is being fed into that particular AI models. The entire pre-processing is to be done. So if the data goes into the black box, AI models such as the deep neural networks or the large language models, the system may generate the decisions in this black box. So without explanations, this creates untrustworthy cyber decisions because users cannot understand why the model reached to a particular conclusion. So as a result, the cyber user feels uncertain about relying on these outcomes in the real world scenarios. So in contrast to this, if the same data, whatever we're getting from the data is being fed to the XAI, explainable AI model, the decisions come with the explanations. So XAI uses approaches like the rule-based methods, decision trees, SHAP, or LMA, which we discussed in the previous slides, to make it more transparent and more reasoning. So that ensures the trust, and this ensures the three things like automation, intelligence, and any kind of trustworthiness. So as a result, we get trustworthy and reliable cyber decisions. So the cyber user feels confident because the AI provides a human understandable explanations. So the key message is black box AI may be powerful, but it is risky. While if you're considering the case of an XAI, it combines intelligence with the trust, making AI decisions more usable in the real world cyber applications. So all I can say is AI makes the cyber security faster, but XAI makes it understandable and trustworthy in today's environment, where cyber threats evolve faster than ever. So this combination is not just nice to have it, it's essential for each and every one for protecting critical infrastructure and the kind of sensitive data. That's the role of XAI plays in the cyber security. Then comes the role of green and sustainable IoT with an XAI. When we think of IoT, we often think of the connectivity and the intelligence, but there is a hidden cost of also energy consumption, e-waste, and carbon emission. That's where the idea of green and sustainable IoT comes into existence. So, the green IoT is about reducing the environmental footprints of billions of connected devices. So when we add the explainable AI to this, we not only make the IoT more efficient, but also more transparent and accountable. Let's say this with some sort of case studies. So basically, if you have seen in this slide explains you highlights you the sustainability challenges in IoT and how XAI helps to address them. Firstly, look at this kind of challenges. IoT networks and the devices consumes a high amounts of energy. So the rapid growth of any kind of device creates a e-waste and life cycles management issues and large-scale deployments. All this contribute to the carbon footprint. So to tackle all this, we have the green IoT solutions like energy-efficient sensors and protocols like low-power 6G and LoRaWAN, powering IoT through renewable such as solar, or kinetic or ambient energy harvesting, and applying AI for the smart resource allocation, making sure devices and networks use energy efficiently. But here's why the explainable AI plays a critical role. AI may optimize that particular energy, but XAI explains you why certain optimizations are chosen. So this helps balance performance with sustainability goals and ensures transparency for ESG reporting and the compliance. Now let us see some sort of applications also. In smart grids, XAI can explain why certain load balancing decisions are being made. Even in the smart cities also, it helps to optimize the traffic or lighting with the clear reasoning. And in healthcare IoT, low power variables can route the data in eco-friendly ways with explanations on the trade-offs. So the key takeaway from this particular slide is green IoT ensures the sustainability, but when combined with XAI, the explainable AI, it adds the crucial element of trust, transparency, and accountability, making sustainable IoT not just effective but also explainable. Finally, coming to the electronics and communication engineering research and career scope. Why this is exciting for ECE students and the professionals? Yes, electronics and communication engineering plays a foundational role in healthcare IoT innovations. Even the chip design is very critical and crucial because every milliwatt speed we saved means wearable lasts longer, making them practical for the patients. Even the sensor miniaturization allows us to create the smaller and less intrusive devices, making the healthcare monitoring systems more comfortable and user-friendly. So with 6G IoT systems, we can even think about the real-time healthcare applications also, like remote patient monitoring and even the telesurgery. So looking ahead, the tiny ML with XAI combined with explainable AI could explain or to enable variables that run AI locally and explain their predictions, even with the digital twins. So digital twins can simulate a patient's organ or a body for safe treatment. That's what we have studied till now, testing before any kind of actual procedures. And even with the 6G surgeries is also possible. Imagine remote surgeons where AI provides live explanations to assist doctors and improves the trust. This is why ECE is not just about the circuits and signals. It's about shaping the future of healthcare with IoT. How many of you are interested in research startups or patients in the case of healthcare IoT? Even if you are not thinking about it now, remember, this is one of the fastest growing industries. Startups in healthcare IoT are ready to booming worldwide right now. So finally, I want to conclude that electronics and communication engineering with Internet of Things combined with this explainable AI gives us the trustworthy smart healthcare. This is not just about the technology, it's about saving lives with trust. So my challenge to you all is, think about how you as a future engineers can contribute through research, startups, or innovation to build the future of explainable AI or explainable healthcare systems. Thank you.